Welcome to a video on forensic identification using the SNOW protocol, focusing on the case of Mario Rossi, or an Italian John Doe. This presentation examines three techniques: biological profile estimation, dental analysis, and radiographic comparison, as applied to a real case documented in 2017. The SNOW protocol, created by Clyde Collins Snow, is a 10-question ethical protocol for forensic anthropologists to identify human remains. It covers everything from determining if the remains are human to the cause and manner of death. His protocol encompasses a series of analytical techniques applied in sequence: scene recovery and documentation, species determination, biological profile estimation, trauma analysis, dental analysis, radiographic comparison, and, where applicable, craniofacial superimposition. Each technique builds upon the last, progressively narrowing the field of possible identities until a confirmed match is established. In this presentation, we will focus specifically on three of those techniques: biological profile estimation, dental analysis, and radiographic comparison. Our case study focuses on an unidentified man whose remains were found in Italy in 2017. I've named him Mario Rossi. The remains were slightly decomposed, lacked identifying documents, and only a pack of cigarettes was found near him. The case examined here was published in 2022 in the forensic journal Sciences Research under the title "The Need for a Complete Dental Autopsy of Unidentified Edentulous Human Remains." In keeping with standard practice in published forensic case studies, the identity of the individual is not disclosed. Biological profile estimation involves estimating age, sex, ancestry, and stature from skeletal remains. This step is crucial as it narrows the pool of possible matches by half or more, using methods like skeletal morphology, bone density, and cranial features. Biological sex is typically assessed through features of the pelvis and cranium. Age is estimated through indicators such as joint degeneration and bone density. Ancestry is determined through cranial morphology, and stature is calculated from long bone measurements. The second technique is dental analysis, also referred to as forensic odontology. Teeth are among the most durable structures in the human body, resistant to decomposition, fire, and physical trauma. This makes them particularly valuable in cases where soft tissue identification is no longer possible. A dental autopsy involves a comprehensive examination of the oral cavity, including the teeth, jaw structures, any dental restorations, such as fillings or crowns, and prosthetic devices such as dentures. Full dental radiography is also conducted to capture the internal architecture of the teeth and the surrounding bone. The third technique is radiographic comparison. This method involves comparing X-ray images taken of the remains after death, known as postmortem radiographs, with X-ray images taken during the individual's lifetime, referred to as antemortem records. Forensic examiners look for consistency in both bone morphology, the pattern of bone, the presence and placement of surgical hardware, and dental features such as root shape and restoration placement. Radiographic comparison is recognized by Interpol as one of the three primary methods of forensic identification, alongside DNA analysis and fingerprint comparison. Its particular strength lies in cases where unique anatomical or surgical features are present that can be directly matched across records. Returning to the 2017 case, the forensic team's first job was already done for them. The partially decomposed body already provided an idea of sex, stature, ancestry, and time of death. The only thing left to do was an ontological assessment, meaning the structured analysis of the teeth, jaws, and oral structures. Because of the little decomposition, records can be compared against those of missing persons. Eventually, the sister of the victim came forward reporting her brother missing and was brought in to ID his body. This biological profile was then used as the foundation for identifying which came antemortem records to request and compare. Without this initial narrowing of parameters, the subsequent dental and radiographic analysis would have no clear starting point. With the biological profile established, the forensic team conducted a full dental autopsy. This included an intraoral examination, detailed photography of the dentures, and a series of 42 radiographic images of the jaw structure. During the process, examiners noted a significant finding: evidence of prior facial trauma and a surgical repair to the mandible. specifically an osteosynthesis procedure in which metal hardware had been used to stabilize a previously fractured jaw. This was highly individuating feature, one unlikely to be shared by many individuals within the same demographic profile. The family of the individual confirmed awareness of this prior surgery, which prompted the retrieval of relevant antemortem records. The final step was radiographic comparison. The postmortem radiographs of the jaw were compared directly with an antemortem panoramic X-ray on file with the individual's dentist, as well as the surgical records from the hospital where the mandible repair had been performed. The comparison revealed full consistency between the antemortem and postmortem images. The location and morphology of the osteosynthesis hardware, the surrounding bone, architecture, and the dental structures all matched. The identity of the individual was confirmed. Critically, no DNA comparison was required. The layered application of biological profile, dental analysis, and radiographic comparison was sufficient to achieve a positive identification. In summary, Snow's protocol is a layered system where each step builds upon the last. In this case, dental and radiographic methods alone confirm the identity, emphasizing the importance of accessible antemortem records.